Thank you very much for attending this talk. I'm very happy to be here. As Katarzyna said, I'm Federico Maggi. I'm a postdoctoral researcher at Politecnico di Milano Technical University. And I'm very happy to be here to present you my project, which is called AndroTotal, which you may guess has something to do with Android. So let me give you a quick roadmap of my talk. First of all, as we are talking about Android, and this is a security conference, we're going to talk about what are the threats and the countermeasures of the Android ecosystem. Then I will take a look at what are the limitations of the security approach employed by Google Android. And later on, I will start with the central part of my talk, which is about testing anti-malware detection systems, anti-malware systems. Actually, the original version of the original title of this talk was a platform to evaluate antivirus system. But since malware is a more modern term, I preferred that I substituted malware instead of virus. So anyway, then I will talk about AndroTotal and the current status of development and how many data we have collected and what is the interest that we had received by the community so far. So let me start with the part about what are the threats about Android against the Android system. So I bet I'm not giving you any big news if I say you that Android is the most popular platform for mobile devices. It actually holds more than 97% of the market share. I'm saying more than that because these statistics are a couple of months ago, so I guess it's increasing. And as it happens usually when a platform becomes very popular, it is also interesting for attackers. It is a very attractive target because there are many users, many potential victims. The attack surface is very large. And so we have seen, I mean, anyone knows, if you know something about the security of Android, you might have heard of this big phenomenon of Android malware. So let's take a look at some numbers, which at the first sight may look quite controversial and quite contradictory. So I took the latest reports of 3 vendors. I know that there is McAfee here, but I don't know if it's the McAfee antivirus division. Anyways, I didn't want to point my finger to any one of these vendors. I just took 3 of them at random, just to show you how different these numbers are. If you took the latest report about Android security threats or Android malwares, you see that Symantec believes that they have 300,000, 4,000 something threats. McAfee says they have 60,000, and Trend Macro say they have 500,000. So this looks quite contradictory, but the point that I want to make is that it is not important what is the size of the threat phenomenon. The important thing where every vendor agree is that there has been an increase in the latest 2 years in the interest of the attackers in distributing malicious applications. So this is the number. This is taken from Trend Micro, but you can take any graph from other vendors and you will see a similar trend. What all the vendors are agreeing on is that the number of malicious applications found on third-party markets or on also on Google Play Store, it is increasing. So we can say that there is an interest in the attackers into distributing this application to try to infect the victims. Let me get back one slide to this last bullet, which is actually I added it yesterday night. I've seen Google's presentation at Virus Bulletin conference last week, where they say that actually the size of the threat is not a good representation of the size of the infection rate. They say that the number of threats is a vast exaggeration of the phenomenon of the malware problem. Basically, the point that Google is making is that they found a very low infection rate thanks to their data. They've measured that they have, I guess, 1% infection rate regardless of the big amount of malware that we have around. So we have seen that there is this increasing interest. This is something that usually, I mean, this is something that shows us that there is a motivation behind it. So let's see what are the goals of the attackers. Well, since we have, we use our mobile devices to store and exchange lots of sensitive data, the number one motivation for the attackers is to steal this data. For instance, think about how many sensitive information you have on your email, on your notes, on your SMSs. Think, for instance, when you exchange an authentication number with your bank account to make a wire transfer. Another important thing that the attackers are interested in is to turn these devices into botnets. So to use devices as a network of control computers to perform malicious actions through them afterwards, or just to exfiltrate interesting data later on. Then there is the financial gain motivation. There are premium numbers, premium phone numbers, that if you call them, they will pay a commission to who have registered those numbers. So the idea is that there are malicious applications which have been disguised as a benign application from a malicious developer, who will get a commission every time this application gets installed on your device and starts sending out text messages or phone calls to this premium number. And this is a direct financial gain. So as I said, Google is taking very seriously security, of course, of the Android platform. And we can see it directly because 1 year ago or 2 years ago, they bought VirusTotal, which is the leader. Well, I'm not commenting on that anyways. I have a slide about VirusTotal afterwards. Anyways, Google, what it's doing is taking what they call a layered security approach to the malware problem of Android. First of all the applications and all the developers that publish application on the Google Play Store, which is the only official market, get controlled automatically and sometimes also manually. So each developer has a profile and a reputation, a sort of a reputation score. And if they see a developer with a low reputation score publishing suspicious application, they will probably block it. So this is the first barrier that they put on to protect against the malware problem. The second barrier, it's actually a quite weak barrier, but if we think about it, no other mobile platform has that. If we take iOS, when you install an application on iOS, you just install it and boom. On Google Android, actually, you have to approve the permission. I know it's the human user is actually a quite weak link because it would just say, okay, I want this app, let me just install it. But it's some measure that no other platform have. The third barrier is a recent one. And it has been deployed to fight against the third goal, financial gain, premium numbers. So what Google has deployed in the latest version of Android is a system that basically tries to detect if one of the applications installed on your system, on your mobile devices, is sending out an SMS or a call to a blacklisted number, or it's sending too many calls or too many text messages. This raises an alert, and it will block the application. And then they have these, what they call app verify, which are actually runtime checks. What they do basically, whenever an application gets executed, the first time it gets executed, it will call home, actually it will call Google servers to verify whether that application is known to be malicious or not. And last and most important, there is the app sandboxing mechanism. So the app sandboxing mechanism has to do with how the Android system works, the operating system. So let's take a look at the architecture of Android. We have the hardware on the bottom, which can be an emulator or your actual phone. Then we have a slightly modified Linux kernel, so pretty popular. And then on top of that, we have a certain amount of instances of app processes. So whenever an application in Android is installed, a new Linux user is created. So there is one unique Linux user, distinct Linux user per application installed. And whenever an application is executed, it will get executed with that privilege of that user, with that user ID and with that group ID. So all the applications are basically like distinct user in a multi-user system. They are separated by privileges by the underlying operating system, so they cannot interfere with each other. The second measure is actually that the applications are not run natively on the bare operating system. They are run within a virtualized system called Dalvik. It's a virtual machine. And what happens is that instead of executing directly, as I said, they execute through sort of a Java virtual machine interpreter, which is called Dalvik. And even though this is not a security measure per se, it guarantees that there is a decoupling between the underlying hardware, the operating system, and the application. So in the future, they will be able to develop fine-grained controls between the app, between what the app is doing and what the kernel is serving. So this looks great, but it has some limitations. So let's take a look at what are these limitations. First of all, the first limitation is that an anti-malware application, so an antivirus that you install on your mobile device, is too constrained. So if we get back to this architecture diagram, we see that each application is an isolated process. It's an isolated execution environment. An antivirus is nothing different from an application. So when you install an antivirus, you're actually installing nothing but an application. So what happens is that they have no way to interfere with other applications. So it is different from a desktop antivirus, because desktop antiviruses run in a completely different runtime. They are able to talk to the kernel and say, hey, kernel, tell me what's executing. Let me know whenever a certain system call is executed so that I can tell if a certain running application is doing something bad. This cannot be done on Android, because up to now, actually in the devices that are shipped on the market, there is no, primitive support for talking to the kernel and say, hey, I want to know what that app is doing. And of course, there is no way for an antivirus app to interfere, to actually audit what another app is another app is doing. So the workarounds that the security vendors are adopting, I'm not saying they are a full solution, but we are getting to there, it's to use signature-based matching. So they basically have a list of known malware signatures, and they compare the installed application against that list. And if the malware has a matching signature, if an application has a matching signature, they will signal that to the user. Sometimes there are kernel patches which have not been shipped to the market yet, but still there is a way that if you install a custom kernel, as I said before, you can develop a custom application module able to talk to the kernel and say, hey, I want to know what that app is doing. Or there are some antiviruses that allow to do more than a simple static check if the user is able to root the device and give that application root access. Of course, this has the problem of also increasing the attack surface of the devices itself. On the other hand, also the malware is quite constrained, because on one hand, if we have seen that the antivirus is an isolated process which is not able to interfere with other applications, in the same way, also a malware is not able actually to interfere with another application. Because remember that a malware in the Android terminology is nothing more than a malicious application. So it's just an application that runs as other application and performs malicious actions, such as sending spam or receiving or sending text messages to premium numbers. So a malware in the Android ecosystem has much less freedom than it used to have in a desktop environment. So it's much more simple. And the workarounds that the malware authors are adopting are using social engineering to get their malicious application installed. So instead of having a sort of an infection what they can do is actually only to persuade the user to install a malicious application, maybe by disguising that malicious application as a benign application, for instance, by promoting, I don't know, a free version of an otherwise paid application. This happens very often. And another countermeasure that they are adopting to work around this is signature evasion. So as I said before, the only way that an antivirus have to detect a virus on an Android phone is by using signature matching. So they use static signatures. And the most obvious way to circumvent that is to obfuscate the malware as many times as it's needed to create new variants of the same family. And we can see that from this trend published by ESET. We can see that there are more variants, actually, than single families. We can see that in 2012, we had much more variants of the same family than we had the previous year, and it's like that for many, many families. So actually, the landscape of the Android malware families is very little, but we have lots of variants. And this is due to the fact that the malware authors keep creating new variants over and over of the very same family. So just to give you an overview, I just wanted to give you an overview of what are the reasons why the malware phenomenon is so so big, according to the media, and why and what are the vendors doing and what are the malware authors doing. This brings me to giving you the core of the presentation, which is about how do we test the performance or how do we evaluate how the anti-malware systems work, or how do we offer a tool to the research community or to the vendors themselves. We have received many contacts from the vendors if they want to evaluate their products. So in the academic research, there is a quite well-established way to test anti-malwares. This brings back me to, I think, 5 years ago or something like that, when the first paper on how to test anti-malwares on regular machines has been published. So the usual workflow is that we get a certain number of samples of known malwares. Then we apply to them a certain amount of code transformations. For instance, we obfuscate every sample in many different ways. And in this way, we produce M by T variants. So we have a larger base of variants. And then we analyze all these variants with P anti-malware apps. So we have a number P of anti-malware apps. And we repeat this procedure on different Android versions. So for instance, we want to test how well a certain vendor works on Android 2.3, and then we want to repeat the same test on the same malware base on Android 4.1. If we do some math, even though we take a very small number, which is quite conservative according to the previous amounts that we have seen in the very first slide, if we take a very low amount of malware samples, 1,000, this brings us to running some millions of tests. So it is quite difficult. I mean, it's not difficult, but it takes a lot of time. And we want some tools to automate this process. We have noticed that there is a lack of automation tools in Android. And the reason is that it is not easy to perform automated tests on Android applications, especially in Android anti-malware applications. So as I said before, there is VirusTotal. VirusTotal, for those who don't know what it is actually a web service that allows you to test one suspicious file, for instance, an executable file or a zip file, against 48 or 49, I don't remember, different antivirus. And these include also antiviruses for Android. Actually, instead of using the native versions of the Android antiviruses, they use the command line versions of the desktop antivirus enriched with a database of signatures of a known Android malware. So they have the old school command line version of something that is not meant to be run on Android, which is a desktop-based product, and they basically added signatures for Android malware. This works great as long as the signatures are the same and the products that run on a desktop behave the same on Android, and as long as we are satisfied with that. Actually, we were not satisfied. We wanted to do something more accurate. We wanted to test the actual products of developed specifically for Android on a real Android device or on a real Android emulator. And another thing, they have no versioning support. So if I wanted to make like a retrospective analysis of how quickly a certain signature was developed against a certain specific malware, I cannot do that with VirusTotal, because I cannot go back in previous versions of a certain anti-malware product. Talking about the state of the art, and I'm talking about research state of the art, it's quite a new thing. There are 2 papers. One was published last year at the DIMBA conference, and it focused on proposing new ways to obfuscate malware for Android in order to detect whether or not after a code obfuscation, the same vendor will be able to detect or not the variant. And the same thing has been done 1 year later, actually in improved research, and it was presented at Asia CCS. It's called Droid Chameleon, and it's basically another set of mutations that can be applied to Android applications to evaluate how robust a signature is against the mutations. And of course, I'm not blaming the vendors. I don't want to blame the vendors, because we have seen that all the vendors can do, the best that a vendor can do is to use static signatures. So it is not a big surprise that if you obfuscate a malware, the vendor cannot detect it anymore. Or if you encrypt a malware and then you install it, and when you're running, you decrypt it, you malicious developer, it is very, very easy to evade detection in that way. So I don't want to blame the vendor. I'm just saying this research gives me no big surprise. And then there is the first paper which was presented last year at Virus Bulletin Conference, which presented something along the line of AndroTotal, but they required a human oracle to validate the results. Of course, we have seen that this cannot be done with the 3 or 2 million of tests that we have to run. So it's quite a human-intensive task. And this is what motivated us for creating AndroTotal, which was a play on word on VirusTotal. But anyways, so we have seen that we have a quite huge collection of malwares that we want to test. So the first requirement is that the architecture must be scalable. No big surprise. And this is actually quite a difficult requirement, because anti-malware for Android are UE-driven. So there is no command line that can be executed. Just, you cannot create a script that runs on 1 million of applications and then you're done. You have to automate all the analysis. So what you have to do actually is something like this. If you want to automate the analysis of an antivirus for Android, you have to tap here. You have to open an application. You have to tap here. You have to request scan the whole device. Then you have to wait for the scan to be completed. And then you have to screen scrape the interface in order to get the outcome of the scan. So it is not quite easy. Let me go back. Sorry. So this is why we created AndroTotal. AndroTotal, it is both a web service, but first of all, it is an SDK. We wanted to make AndroTotal an SDK because we wanted to make it extensible. So we wrote an SDK that we call AndroPilot, which is a set of Python libraries that allow to write UE interaction tests. We have reviewed all the available tools, and we have improved them, and we have created our own version. So basically, what we have is a set of pluggable modules on top of each anti-malware application for Android that allow to automate completely and to abstract completely the testing of one product against one sample. And of course, the tests that we can write are parametric with respect to the version of the product and with respect to the version of the Android system. As I said, there is a web front end for human user. And also, we have a web service which exposes a REST JSON, call it whatever you like. It's a quite fancy name. An API for machines, so that you can plug our system into your own applications. And then we have created a set of pluggable code transformation modules. Meaning that you can ask AndroTotal to obfuscate a sample with a certain amount of obfuscation techniques before the scan. And we have done it, but we're not going to release this module publicly. Probably we will never release it, because our purpose is not that of doing comparative analysis or to point our finger to that vendor saying, hey, if I obfuscate a sample, that vendor is not able to detect it anymore. We don't want to do that, so we'll keep these for our own internal researches, and if a vendor is interested into testing his own products with a certain amount of transformation in the code, we are very happy to talk to the vendors to give access, private access to this module. In theory, AndroTotal works also on physical devices. I say in theory because we haven't tested it yet. We have started in April 2013. We haven't tested it physically on a real Android phone. We use it on emulators. In theory, it works because we use a non-modified emulator. So whatever runs on an emulator should work on a physical device. This is what the emulator is for. So we haven't tested, but we are planning to do that. So I want to give you an overview of how it looks. Let me go back one. Here, okay, so this is what you have. Here we have a CAPTCHA because we don't want people to screen scrape our interface. So you can select the number of vendors and the version. Say, for instance, we want to compare, whoops, sorry. We want to test Avast version 2.0, 33080 against Avast 2.0 or whatever. And then we want to run a test on Trend Micro. And here on this test, we have used Android version 4.1, and we applied the detection method on the installation of the potential malware and on demand. And I'll show you in a minute what that means. This is the result that you will get back. So you will get back the detected labels, and a summary page with the latest 10 scans performed on that very same sample. Now we also have integrated AndroTotal with VirusTotal, Sendroid, and many others. This screenshot is quite old, but we have integrated with other tools to analyze and to exchange data. We are always happy to do that. And here you can see the screenshot that we take right before screen scraping the interface. So we can see that this antivirus, for instance, has detected this particular application with this particular name. And here you can see a dump of the log file that we save and we let the user download for later use. We also collect the network traffic. And here, as I said, this is beta only. We're not going to release it to the public. This is code transformation. We support 10 or 11, I don't remember how many of these, I don't want to count them, transformation attacks, transformation operators. So before scanning a certain malware with a given vendor, with a given antivirus, you can chain together as many code transformations as you want. There is a plus sign here. You can click, 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 and add, I don't know, go to, NOP, rebuild, reflection, and your malware will be modified before scanning. So let me give you a little bit of details of how easy it is to write a test unit for an Android malware, for an Android anti-malware with AndroTotal. So as we said before, this is the procedure that we would like to automate. And this is what usually a user will do to scan his or her own device to see if there is a malware on that. This boils down to a few lines of Python code. This is a class called test suite, which extend a base test suite. Here we define a function to automate the on-install detection. That means that we want to test whether or not the anti-malware is able to detect a certain application as a malware when we attempt to install that application. So we leave the anti-malware sort of dormant, so we do not execute it explicitly, but we try to install a malicious application. And then we wait until we see a reaction. If we see it, we screen scrape the interface to get the label, and if we don't see anything, we just return false, which means not detected. And you can see here that it's quite abstract, it's quite easy to understand. We have a self-pilot call to install package, which means install a certain application, malicious application. And then we stop. We stop for the activity called COMMS owner Android antivirus common X-scan results, which is the name that characterizes the activity screen that shows up, that pops up whenever a certain detection is triggered. And if we get something, we try to screen scrape, as I said, and if we don't get anything, we just say result false. And here is another detection routine that can be implemented. This is the on-demand detection. And this is different from the on-install detection because certain anti-malware products allow to test whether or not there is a malware explicitly by scanning the whole device. Actually, not the whole device, but the portion of storage that they are able to see. Because as I said before, if the device is not rooted, and the anti-malware application is not given full access to the full device, to the full file system, they can only inspect a portion of the file system on the device. So here what we do is we install the malicious application again. Then we start the activity of the anti-malware. So we actually tap on the application button. And we wait for that. And after that, we tap on certain coordinates which correspond to the button scan whole device. And then we wait for the activity. If we get something, again, we save that there is a result. Otherwise, we wait. And if a timeout gets triggered, we conclude the test and we say that we don't detect anything. So this is basically pretty much similar to what we had here from here on. So what happens under the hood when you execute one of these tests is that AndroTotal creates a clean Android emulator image. So we have a database of clean images downloaded from the official Google ROM repository. What happens is that we take one of them, we instantiate it, and we run it into the emulator. Then we upload or we install the suspicious APK, the suspicious application. And then we instantiate the test script and we launch it on different workers, depending on how many tests the user has asked. We have a set of parallel workers that work in parallel. We instantiate this test in a queue and they get dispatched to the workers. As I said, we have an API. We have an API interface that every developer can use. And we recently released a Python client that you can download from here. You can contribute to that if you want. This is open source. Scanning an application is as simple as executing this command line. So you basically have to register to get your API key, of course. And here you basically tell, I want to analyze with AndroTotal these and these and these and these many samples. And you get the results back as a JSON file. Whoops. Actually, what you get back is, since we run our tests in an asynchronous fashion, you get back an identifier that after a while you can check back the result. So now I want to conclude with what is the status of development of Android and what data we have collected. Since April 2013, we support 13 anti-malware vendors. Not all of them are public, because some vendors didn't want to appear on the public interface. So we keep it on our beta version, which is running in our lab. And we have 16 products overall, which means that we have multiple versions of the same vendor. About 1,300 users subscribed. They requested access to the API, and they are pushing samples. And so far, we have collected these many distinct applications, and we have analyzed them with our infrastructure. This is a sample. This is the list of the supported applications so far. We have some students working on thesis, developing other adapters. But this is what we support so far. So we have a couple of versions of Zoner. We have one version of Avast. We have a couple of versions of Kaspersky, Trend Micro, Norton Mobile, and so forth. This table gives you an overview of what is the popularity of the labels that, of course, I forgot to mention that these are not all malicious applications, of course. These are both benign and malicious. We don't know what they are when they get submitted, of course. And this is a breakdown of the most popular labels of the malicious application. So what the vendors, what at least one vendor detects as malicious. And you can see that the labels look pretty much all different, but this is a common problem in malware labeling. I've done some research a couple of years ago about how inconsistent the labeling of the samples are depending on the vendor, and how this is a problem if you want to cross-correlate the results of different anti-malware scanners. But anyways, I just wanted to give you a glimpse on what data we have. This is an anonymized slide. This is vendor 543 because we don't want to make comparative analysis. And this is the average time to complete a test on the whole file system of an emulator. And this gives you an idea that there is no big winner. So pretty much all the vendors that we have launched this test on have a wide variance depending on how big the file system of the device is. It can span from 30 seconds up to 3 minutes, but there is no, you can say that there is no big winner in speed, of course. Okay, I'm almost done. I just wanted to give you a few points on what we're planning to do for the future. Of course, given the interest that we received from the research community and from the vendors, we wanted to throw more hardware, to throw more computational power to AndroTotal, because now we are limited to a few computers, and we would like to scale a little bit more, because our workers are having quite a hard time to process all the workload. Then we would like to compare the labels and the detection results with virustotal.com, because this is what motivated us to create AndroTotal. So we wanted to see if there is a difference between the database of signatures used by vendors that produce a specific version of a desktop antivirus and the same vendor that produced the same version for Android. Then, as I said, we wanted to deploy our system on physical machines. So we would like to get a bunch of ARM boards or some inexpensive cell phones to run as physical workers, because in this way we can get some more interesting data that you cannot get from the emulator. For instance, you can measure how much battery power your antivirus consumes, and this is very, very important to know, because battery power in cell phones is a very valuable resource. So if you have a battery that lasts 1 day, I'm not sure if you want to have a running antivirus that keeps keep track of what you're doing, consuming your battery. So this is quite important because it may create a barrier of acceptance to the end users with respect to antiviruses. So if an antivirus is quite efficient, then the cost of adopting it on a device is quite low, and the acceptance will be high. Last, and most importantly, we have plans to create a repository of an open repository of malware samples for Android that we would like to we'd like to create these sort of a big repository with an open API as a collaborative effort to gather more samples and to gather more analysis. I've seen from previous talks that there are people that have a lot of data. I'm not sure if these people also are interested into having data about mobile malware. I'm interested to provide data. We have provided it to who I requested. And I'm also interested to get data, of course, and to give results back. So this big repository would like to be our, give back to the community who have provided samples to our system. So I would be happy to give you to answer your questions, and I will be happy to give you a sticker. We have made AndroTotal stickers. Thank you. Yes.
Hello. I have a question. You said only about Android, and I'm curious, have you ever tried to compare Android with other operating system for mobile devices, for
Such
example,
as Symbian or iOS?
or
No, we haven't. The reason is purely technical, because there is a lot of tools available for Android. Android is 99% open source, and for instance, it's quite easy to get automation tools and tools to work with that. But for iOS, it's quite hard. So we haven't looked into that.
I'm asking because today people like to compare few.
What do you mean compare? You mean compare? The amount of malware for.
That's the question. Which system is better? I know it's really hard to say, but
it's actually I don't think there is an answer to that. What I can say is by citing what I've read recently on a Symantec report. I guess it's Symantec. I don't remember. But basically, the point that they were making is that the vulnerability surface, so the open door on iOS, is much larger than on Android. But given the fact that Android is open and the ecosystem is open, they let every developer to enter a market. There is unofficial markets, very easily accessible to users. You don't need to modify your phone to install a third-party application. For this reason, the attack surface is much larger on Android. So it's like the difference between living in a safe neighborhood with the door open and living in a very unsafe neighborhood with the door closed. So there is much more interest in Android, but there is more vulnerability space in iOS. That is pretty much my answer. Yes.
So comparing to VirusTotal, do you maybe think about providing like a general way for a typical person from the street to upload some application to check? Like VirusTotal has a desktop app that allows you to upload any file and check.
Oh, you mean the toolbar?
Yeah, toolbar or something like that. Do you think about providing something like that?
Well, now we have, we are allocating our resources, which are not very, very high due to recession, and in Italy, Ministry of Research is not giving out a lot of money. But anyways, we are putting our resources on improving the current infrastructure. What we have thought of doing was to create a client application for Android, but we are not 100% sure that we want to do it because it's basically giving free access to. I mean, if we do it, we will do it only if we keep free versions of the antiviruses on the system, because we don't want to give free access to, I don't know, 10 products or to otherwise paid services. But yes, we have thought of it, and it can be done quite easily, I guess. It's just a development effort, because the API is there. You upload the sample through the HTTP API, JSON API, whatever it is, and you get the results back in JSON. So it's pretty much open. I think it can be done. If anyone here is interested into collaborating, as I said, it's open source. I mean, not the whole product is open source, but the clients are open source, and the interface is open source. So we might do it.
Yeah, and I have a follow-up question. Your service seems like a very interesting thing for Google actually to integrate into their
This
own.
one?
Yeah, because why not provide feedback for Google Play Store and mark some applications as suspicious or whatever, depending on the score, for example?
I think that the point of Google if you want just to know whether a certain sample is a known malware or not, VirusTotal is perfect, because you get the yes/no answer and you get the label. But if you want to test and you want to study how well the Android application that performs the antivirus check works on Android as if it were the actual device, then AndroTotal is made for that. So VirusTotal is good for detecting yes and no. And I guess that's why Google acquired VirusTotal. We are more, we wanted to just to know more about how these antiviruses work, and we want to get more, we want to be complementary in some way. For instance, with VirusTotal, you cannot measure how much your battery will be discharged if you run a test, if you run a scan on your device. With AndroTotal, you can. With VirusTotal, you cannot test it against 10 versions of the same product. With AndroTotal, you can. So it's pretty much a complementary.
Thank you.
Sure. Thank you.
Thank you very much, Federico. I think time for questions.
Thank you. Yes, thank you very much.
Finished.